Assalamualaikum. Today our group want to present about neural expert system for identifying major risk factor of breast cancer. This is our group member Nurul Wajihah Karimah binti Muhammad Shukri, Nur Syazwani binti Ahmad, Nur Aisyah Tasnim binti Muhammad Zainuddin. This is our table of content, and let's start with background of application. Today, breast cancer is very common cancer in women. Each year, the number of deaths related to breast cancer is about 2.1 million. Every year, the cases involving breast cancer are increasing. This breast cancer disease is caused by several factors. Among them are age, family history and medical history. Breast cancer can be prevented to some degree, but there are some factors that can be controlled. These are weight, physical activity, alcohol intake, smoking and else. Many intelligence systems has been proposed using different machine language technique. For early diagnosis of breast cancer, neural network (NN) is considered as one of the best machine learning classification technique. In this report, we propose a medical expert system which named Transparent Neural Expert System for breast cancer to manage breast cancer by identifying major risk factors. The proposed Transparent Neural Expert System for breast cancer adopts the white box NN model which named Rule Extraction from Artificial Neural Network (ANN), applying classified and misclassified data. For rule extraction from breast cancer database, the rules are generated in this system which are most transparent to verify the major risk factor of breast cancer. The purpose transparent neural expert system for breast cancer algorithm is comparable the RS-RAN algorithm. The experimental analysis is noticed that TNESPC algorithm perform better than RS-RAN. The comparison is formed using 10-fold cross-validation CV accuracy, average recall rate, average number of antecedents per rows, and average false positive. That's all for me. Next, I will pass to Nur Aisyah Tasnim.
I am Aisyah Tasnim. I will present the methodology of application. As you can see, this figure shows the phases of the Transparent Neural Expert System for Breast Cancer, TNESP. It consists of 6 phases: data representation and network training, network pruning, data range computation, rule generation, rule pruning, and rule updating. For the data representation and network training, the real-world data is presented in special forms which are suitable for the neural network to take as input by removing all the missing values and converting all the mixed data to numeric value. The real data is represented in form of patterns, which is input attributes as antecedents and output as consequences. A neural network is trained with the patterns using backpropagation learning algorithm. So for the network pruning, the algorithm removes the irrelevant attributes of the network using a reverse engineering technique. Attributes that have the lowest misclassification error are removed from the network if their removal does not affect the classification accuracy of the network. So for the data range computation phase, data range are calculated by taking the significant input attributes. The calculation is done using data range metric. And the next phase is rule generation. In this phase, classification rules are generated using the data range matrix constructed in the previous step. So for rule pruning, the algorithm removes any irrelevant attributes in the rules to improve the classification accuracy. In rule updating phase, the lower and upper range of data values of attributes in the rules are updated. The algorithm updates the range by shifting the lower and upper range. As you can see, we have two rules right here, the RxREN and TNESVC. So the RxREN is a new and popular pedagogical model. The system adopts RxNCM, which is also a pedagogical approach, and therefore the performance of these two will be compared to know which one is more efficient. So to do that, the team has taken the dataset of breast cancer from University of California, which is used for the experiment. All results are examined by using tenfold CV to minimize the bias associated with random sampling. The performance is evaluated against four criteria. The first one is tenfold cross-validation CV accuracy, the average number of antecedents per row, the average true positive rate, and the average false positive rate. So as you can see right here, this is a table that represents the results of the experiment. So for TNESVC, the accuracy percentage is 93.16%, while the RSREN is 91.73%. So for the average, RSREN got 3, while the TNESVC got 2. So for the recall, TNESVC is 0.1983, while for the RxREN is 0.9067. For the false positive rate, the TNESVC is 0.0267, while the RxREN is 0.254. It is noticed that TNESVC performs better than RxREN in the measures for the breast cancer dataset. Hence, it can be concluded that TNESVC performs slightly better than RxREN in this dataset.
Benefits of application: improve decision-making quality. It is proved based on database table in previous session, which is the NESBC algorithm is more appropriate choices in this medical expert system as it is very small computational overhead while producing high accuracy and easily comprehensible rules. Cost effective. This application is a computer vision based. Because of that, it does not require high computing performance systems with expensive hardware, which is making the system is cost effective as it trims down the expense of consulting human experts when solving a problem. The next advantage of this application is provide fast and accurate solution. This approach has decreased unnecessary waiting time and as well as human and technical errors in breast cancer diagnosis. When compared to earlier algorithm, they achieve 99.95% classification accuracy for breast cancer. Moreover, it gathers case knowledge and uses it efficiently. This expert system combines the expertise of multiple human experts, resulting in more efficient solution. Image pre-processing, segmentation, feature extraction, feature selection, classification, and performance evaluation are the main step for this diagnosis. In addition, the advantage of this application is more consistent decisions. When diagnosing cancer risk based on the individual symptoms, this application provides consistency in offering responses to recurrent situations. And the last one is the solve complex and challenging issues, which is also the one of the advantage of this application. The TNESBC expert system emphasizes the concept of rule extraction from artificial neural networks and applying the classified and misclassified data RxNCM algorithm to extract rules, which are then used to identify important breast cancer risk factors. It is primarily a pedagogical rules extraction algorithm, and the backpropagation technique was used to discover its architecture. The RxNCM method is advantageous since it is computational-like and produces the most precise and defined rules. And that brings us to the end. I'd like to thank you for your time and attention.